In our homework example now, we have two wires separated by 10 centimeters. They each have a current of 0.75 amps, but the current is flowing in opposite directions. Find the net magnetic field at point P. So this is going to be a lot like what we did in the example. And in fact, our first wire, if we just look at the pink stuff, this is exactly what we did in our last example. The only difference now is we have two wires. Each of them are going to make a magnetic field. To find the net field at P, we'll just have to add them together. Okay, so our magnetic field B1, so this is wire 1. Magnetic field makes big circles around the wire. We did that in the last part. We know that our magnetic field is a tangent at point P. Our fingers point up, so our B1 points straight up. I'm going to put in my coordinate system, X, Y, and Z. B1 equals 1.50 times 10 to the minus 6 Teslas J hat. Okay, we did that on the very previous example. Okay, what's going on with wire 2? Well, wire 2 flows into the page. We want to find the magnetic field at point P. We know the magnetic field makes big circles around the wire. So we draw a big circle that has the wire at the origin, and our circle cuts through point P. The orientation of those circles, our thumb goes into the page. We make a circle with our fingers. We say our fingers are making a clockwise circle. Comes around like this. The direction at point P itself, so our thumb goes into the page, we make a circle with our fingers, we see that our fingers point down towards the bottom of the page. So there's the magnetic field due to wire 2B2. We can find the magnitude the same way we did on the previous page. We'll use our equation. So our magnetic field B2 has a magnitude of mu naught times I2 divided by 2 times pi times R2. R2 is the distance between wire 2 and our point P. That's going to be 20 centimeters. So equals 4 pi times 10 to the minus 7 Tesla meters over amps times our current I2, 0.75 amps, divided by 2 times pi times 0.20 meters. That gives us a magnitude of 0.750 times 10 to the minus 7 Teslas. B2 is a vector, so we should write it with direction. That's going to be in the negative J hat. To find our net magnetic field, we have to add those two vectors together. So our total field B is B1 plus B2 equals 1.5 minus 0.75 times 10 to the minus 6. Oops, sorry, goofed. This should be 0.75 times 10 to the minus 6. Tesla's J hat equals plus 0.75 times 10 to the minus 6 Tesla's J hat. This is a small magnetic field, but this typically is what we see around current carrying wires. So if you have more than one wire, you find the magnetic field due to each wire, and then you add them up. That's how you get the total.